there! On today's episode of Coding Together, the future of computer graphics! I am going to attempt to render a three-dimensional rotating cube right here on the screen of this Apple II Plus computer. I'm going to see if I can program it all in BASIC. But before I get started, I would love to highlight some of the wonderful messages I've been receiving from viewers just like you. Kelly Murphy writes, the variable name length used by Apple BASIC is 2 characters. What does this mean exactly? Let me write a little program here with a variable called startx, and then maybe a variable called startY. If I print them both out, I should see what? 10 and then 50. But I only see 50. This is because what the computer is storing as the actual variable name is just those first 2 characters, ST. David Frischneck writes, I remember typing in a Mandelbrot plotting program listing from a copy of Insider magazine and letting it run all day while I was at school. I too have been working on a Mandelbrot plotting program on the Apple II Plus, and I'm going to show you a time lapse of it running right now. Mwah! It's so beautiful. Many of you also mentioned Beagle Brothers BASIC, which was an enhancement utility for an Apple IIe or a 2 or 2 Plus with an additional RAM card. One of my favorite enhancements that Beagle BASIC has is a swap command, which will swap 2 variables. And it even includes else. Many of you commented on how there is a way to edit a line of code that you've already written other than retyping the whole thing. Mark Miller explains it as, what I remember is you had to hit escape, and then BASIC would allow you to use the I, J, K, and M keys on the keyboard to move the cursor around to the line you wanted to edit. Aha, okay. So I think what I need to do is I need to hit escape, move up with I. I've got to now press J to move over the 1, and then I can't use K to move across the characters. I have to now switch to the arrow key. Well, first I press escape to get out of moving the cursor. Then I press the arrow key all the way over here. Now I could change this number to 25. Now I could hit enter, home, list. Here we go. I've edited a line of code by manipulating the cursor. Wow. Thank you, Mark Miller. This is going to improve my life as a programmer tremendously. I should also mention that I have since acquired something very exciting. You'll notice here that I have these beautiful disk drives and countless of my old floppies. Supertext, Daniel Schiffman, December 4th, 1982. Beagle BASIC, there it is. This is my 5th grade science project. I should try to load this and see if I can get it to run. Unfortunately, I haven't been able to get these disk drives to work. So I would really like to restore them to access what's on these disks. But in the meantime, I have acquired from Big Mess O' Wires something called the Floppy Emu. The Floppy Emu here is a device that takes an SD card that I can load any Apple II disk image onto, and I can also write to it. So I can load programs and write to it. And on this SD card, I basically can store the equivalent of thousands of floppy disks. And it has a little menu here. So if I go to Apple II stuff, I'm gonna go to 5 1/4 inch disks. Let's go to games. Let's try Frogger. And now you can see Frogger is loaded into the Floppy Emu in the same equivalent way that it would be for a disk. I'm gonna restart the computer. I can see here that it is reading Frogger. I've got the start screen here, space to play. And here we go. I am the king of Frogger! Maybe I'll start streaming these games over on my Twitch channel. I am going to go over here and go to Apple II stuff, 5 1/4 inch disk, and I made a little folder myself called Schiffman, and I've got a DOS sample disk that loads a bunch of sample programs and will allow me to save whatever code I write today onto this SD card and release it to all of you. The first thing I want to talk about is double buffered animation. Now, I've talked about this a bit in previous videos, and we did something like this in my bouncing ball in BASIC example, right? Every time I moved the ball, the rectangle, to the next location, I had to erase the previous one so we wouldn't see the trail of it. We just see this rectangle moving from spot A to B to C to D, etc. Most P5 or processing sketches have a draw loop. Happens over and over again. At the beginning of draw, the background function is called to erase the background. The stuff is drawn. When it loops back, background is erased again, stuff is drawn. Background draw, background draw, background draw. But we don't see that flickering of background then put the shapes. This is because double buffered animation happens behind the scenes. The screen is not actually updated until the end of the draw loop. So all of that stuff is happening in an off-screen buffer that then all at once gets put to the screen for you to see. If I want that same functionality in an AppleSoft BASIC program, I've got to implement that double buffering myself. So let me find where in my manual here, or maybe in this tutorial, where I can find some information about it. Aha, I have found the part of the manual that I need, commands affecting graphics. So I know that the Apple II Plus in memory has 2 pages for high resolution graphics. So one of those pages can be off screen and I can draw to it. And then when I put that one onto the screen, I can start using the other page, then I can swap them. And that's how I'm going to implement this. I can poke the memory address to show one page versus the other. So the first thing that I want to do is start a new program that both initializes high resolution graphics page 1 and high resolution graphics page 2. Great, there's the line. Now, what if what I want to do is animate the line moving across? There's one more step that I need, and it's here on this Beagle Brothers poster. For selecting which plotting page I'm going to draw to, I need to poke address 230. 32, page 1, 64, page 2. I've also printed out for myself a little reference with all the correct poke addresses that I need. Let's think about how we're going to adapt this program to have a line animating across with double buffered animation. Let's actually start over for a second. How high is the screen again? 192 pixels, I think. So here's a program that should start by plotting a line, moving X, and doing that over and over again. Whoops. Oh, H-plot. 192 is correct because it's 192 pixels high, but it's 0 to 191. What am I thinking? There we go. So now this line is animating across the screen. If I wanted to erase the previous line, I could go ahead and do that. Ultimately, my future goal is to draw this elaborate cube, and I know this is not going to be very efficient, and it will probably slow down the program enormously, but when I draw the cube, I'd rather not individually erase each line. I'd rather just wipe the whole page, and I can do that with a call called -3086, clear high-res screen to black. So that's what I want to do. And the positive integer value of that is 62450. So I'm going to, in line 25, say call 62450. And then let's go to 25. Now this is not double buffered animation. This is exactly the problem. We're seeing it clear, draw, clear, draw. Now we need to figure out how to do this process on 2 separate pages. I'm going to have a variable keep track of which page we're on, or which screen. So let's call it SC. And we're going to think of it as screen 0 and screen 1. So what if I were to write a subroutine where the very first thing in the subroutine I do is show the page that I'm on? Actually, the thing is, I've done this before. So I know what I need to do in this subroutine is actually show the other page, because I want this subroutine to be the subroutine that swaps. So I'm thinking about it. I've already drawn it off screen. Now I want to show that other page and start working with the other page. This will make sense. So I'm going to say poke. So it's either 49236 or 49237. Those are two integers that are separated by 1. My screen is either 0 or 1. And by the way, I can turn 0 into 1 or 1 into 0 by saying not screen, because on the Apple II Plus, false is 0, true is 1. So not 1 is 0, not 0 is 1. So poke 49236 plus not sc, comma 0. So this will display the screen that is not the value of the variable sc. And then I need to poke memory address 230, and then going back to setting the page that I'm plotting on. So it's either 32 or 64, which is the same as 32 plus 32 times sc, right? Because if sc is 0, that will be 32. If sc is 1, that'll be 32 plus 32, which is 64. Then what I'll do in this subroutine is clear that one. Call 62450. Okay, let's look at our program. So get rid of 25, and I need to return. So this subroutine starting at line 1000 is just switching which screen we're drawing to. So presumably I will do that at line 50. And then on line 60, I can go to 30 and draw again. Let's just see what happens if I run this. Hello! So what's happening here? I'm just seeing one line. That's because the value of sc never changes. So I start with screen 0, I draw the line, and then I switch to drawing on the other screen, but I never switch back. So somewhere in there, I need to swap screens. After I draw? Yeah. Right before I go to 1000? Ah, look at that! Look at it beautifully moving across with no flicker. It's just very, very, very slow. This does not bode well for my cube. Now I sort of feel like the way that I've done this, it's silly to have this s equal not sc be not part of the subroutine. But I'm sad that I made this first line of the subroutine line 1000. Would it be silly for me to do this? I don't like this at all. So my draw loop in processing terms is essentially lines 30 and 40. So, if I want to really have this be more like processing, bear with me. Let me retype some of this. Look at me editing. That's right. Just edit that line. Yes. Then line 25 would be call. What's the address to erase again? 62450. This now is my draw loop. Erase the background, draw a line, move X. Then I need to go and, 999 is no longer. Go sub 1000. Then this is the line of code that's invisible in processing in P5, the thing that goes and swaps the buffers, which I do there, come back, and then repeat the draw loop. That's got to be, I got to erase the background. So 60 should be go to 25. All right, here we go. It's still running really slow, but I'm so excited that we have double buffered animation. This is amazing. I think we're going to need this book, Programming the 6502. So BASIC is a language that's fun to use and really easy for me to demonstrate and explain, but to squeeze out the efficiency of this computer, I'm probably going to need to start looking at assembly language. I have a feeling also, and I'll show you a version of this, that if I were to just erase that single line instead of clearing the whole graphics buffer, it would also run a lot faster, but that seems like way too much work for me. We are, however, ready now to see if we can start applying some 3D transformations to this line and probably see it run really slow. And then can we make a cube out of a whole bunch of lines? Why not, right? So I'm going to remove right now everything from line 20 to line 60. And let's start by rotating a single line. Now, I know that eventually I'm going to want to have a bunch of lines. So even though I could just have x1, y1 and x2, y2 for a single line, I'm going to have an array that is multi-dimensional, that has 2 spots, each with 2 values. And then when I have 2 lines, I'd have 4 spots, each with 2 values. So on line 20, I'm going to create an array, we'll call it points, that has 2 points in it, each with 2, oh, you know what? 3 values. Because the whole idea of this is we're doing this in 3 dimensions. Now, the other thing I want to do here is I want to think of the space of the window as 0, 0 being in the center. So if I want to draw a horizontal line from 1/4 of the way to 3/4 of the way, my points would be points 0, 0, which is x, would be, let's just consider this line to go from 0, 0 is in the center, and this line is going to go from -1 to 1. We'll scale it later. 0, 1, which would be the y, would equal 0, because it's going to be in the center. I wonder if this is eventually going to be a cube, though. Let's have it be a line along the top of it. So let's have that be -1, and then points 0, 2, which would be the z, we're just going to have the z be 0. So that's the first point. The second point is going to be the same, but the x value will be +1. Now, let's write another subroutine. We'll start it at line 500, which draws whatever's in the points array. No. Let's have a subroutine that draws a line between any arbitrary 2 values in the points array. In other words, hplot, and forget about the z for a second, points a, 0, points a, 1, 2, and the a doesn't exist yet. I'm going to add that in. So this is x and y of point A to the x and y of point B. Then, watch this. On line 50, I can say A equals 0, B equals 1, go sub 500. So this is essentially a way of having arguments to a subroutine. I'm going to set 2 variables, A and B, right before I go to the subroutine. That's drawing a line between A and B. And then line 60, I'm just going to go to 50. Just do it again. We're not doing the swapping yet. Just want to see if this works. Oh, no. But I need to do the scaling. Oh. Okay, so I need to do this a different way. It's nice that I typed all that, but essentially what I want to do in line 500 is say x1 is a 0, and then I want to multiply it by some scaling value. Let's use sz plus half of the width, which is, what was the width again? 280? So plus 140. I probably should put that in a variable. Center x. We're going to have that be a variable. So times the size. So -1 becomes whatever size. Let's say -1 is 50. So -50 plus whatever that center offset is. So that would be over here. Okay, that's x1. The center y. Then I can just say hplot x1, y1 to, no, x2, y2. All right, everybody, ready for some editing? Then 550 is a return. I think this is good. Oh, but I need these variables now. Let's just, at the very beginning, line 12, let's just use 50 pixels for the size. Center X is 140, and center Y is half of 192. Ooh, I've got a line there. I must have messed something up. Oh no. Boy, this has been a mistake for a very long time. All right, ready, everybody? This has to be index 1. I initialized the 0 element of this array twice. I'm going to retype it. Okay, that looks good. Let's run this. There we go. Congratulations, you've watched 45 minutes of somebody on YouTube drawing a line. So we're in really good shape here. The bulk of the work is just going to be typing out a lot more coordinates and then writing a loop to go through and draw all the lines connecting all the coordinates. But before we do that, there is one step here, which is what if I want to see this cube that I'm going to draw, or whatever the shape is, rotate? And there is no, unlike in Processor P5, translate and rotate and push and pop. So I'm going to need to do that with the math behind rotation itself. This is something that I've covered extensively in another video where I did 3D rendering in a 2D renderer by writing all of the matrix math. I'm not going to rehash all that in this video, but I do want to show you the basic math behind rotation. Let's say we have a Cartesian plane, and we have some point x comma y in that Cartesian space. We can think of that point relative to the origin and rotate about the origin by some angle called theta, and it would end up over here. This would be the new x and y position. I've demonstrated how to do this in previous videos looking at the concept of polar coordinates. Ultimately, the way to apply this kind of 2D rotation transformation is with matrix math. This rotation matrix rotates the point xy counterclockwise according to the angle theta. The xy point is written as a column vector, and the new point is the result of that vector multiplied by the rotation matrix. We're going to get a new single column vector, and the first element, the new x, is x times cosine of theta plus y times minus sine theta. Then the new y position is x times sine of theta plus x times cosine of theta. Notice how if x and y was the point 0, 0, the new point would be 0, 0, because rotating 0, 0 around 0, 0, the point stays the same. This is not applying any kind of translation, only a rotation counterclockwise by the angle theta. In the context of computer graphics, we might be going clockwise because the y-axis is flipped. In 3 dimensions, we don't just have a single plane and a single angle. If we apply a rotation, we need to know around what axis, x, y, or z. Interestingly enough, this is actually the rotation matrix for the z-axis, only we need to extend it out to account for z. So to get the new x, we would say x times cosine of theta plus y times negative sine of theta plus z times 0. The new y, x times sine plus y times cosine plus z times 0. And then the new z is x times 0 plus y times 0 plus z times 1. So z does not rotate around the z-axis. We can look at the rotation matrix for the y-axis. As well as the rotation matrix for the x-axis. Now that we've covered what the math is, the things that I need to add to this program are a variable for the angle that I'm going to rotate. We'll start with just rotating along the z-axis, as well as a whole second set of points, because I need another variable to apply that transformation into. So right at line 25, let's call it rotation z points, RZP. And we're going to have 2 of them, and they have an x, y, and z. Oh my goodness, I did forget an important step, which is once I've rotated the point in 3 dimensions, I need to just project it into 2 dimensions to draw the correct x and y. But guess what? I'm just going to use the simple way of doing that by taking off the z. So it won't be perspective, it'll be orthographic, but it'll be good enough for us right now. And now I have a whole separate array for the rotated points. Line 50 is where I'm drawing. So in line 55, let's do another subroutine, 2000, And that's where I'll apply the rotation math we just went through. So for n equals 0 to, and I just have 2 points right now. There's 2 points in the array. Oh, I forgot about an angle. Running out of lines of code here at the beginning, but let's do line 18, an angle. Do I dare? No, I can't use A because I used that here. I could use angle, the word angle. Angle equals 0. Then line 2000, so 2010, the rotation point for Z of I, the X value equals, so I need to use cosine of theta, but as soon as I go to do I comma 1, the Y value, I'm gonna wanna use cosine of theta again, and I don't wanna calculate that twice. So actually, what I should do, even before I do the loop in line 2000, is say CS for cosine of theta is cosine of, and it's not theta, I called it angle, sorry. And SN for sine is sine of that angle. Now I could do that loop for n equals 0 to 1, and then RZP, right? The rotation Z point, X, N, for the nth point X equals negative cosine. You might notice that my original matrix had positive cosine theta, and yet I just typed negative cosine theta. I'm also going to type positive sine instead of negative sine. This is because in the graphics world of the Apple II Plus, Y points down. The pixels are positive in the downward direction, and I want it to match Y pointing up. So I've just swapped the sign there, and the rotation happens in the correct direction. Who's to say what's correct anyway, though, as long as I'm consistent? But I just want to let you know that's why that changed. Times X, which is 0.0, plus sine times Y, which is 1, plus Z times 0. Now, since I'm multiplying by 0, I don't need to have that operation in there. Probably should just leave it out, but I feel like just to have the math be consistent, I should say 0 times points n comma 2. Then let's do the Y. Y equals sine of theta times X plus cosine times Y plus 0 times points times Z. And then, to be consistent, I should do the Z, which is just 0 times X. Again, this is a lot of extra stuff. 0 times Y plus 1 times Z. Next, N to go on to the next point. Now the question is, where in the code do I want to apply this rotation? So right here, starting at line 50, that's essentially my draw loop. Draw the line, rotate the point, then go back and do it again. Draw the line, rotate, draw the line, rotate. But I'm missing the swap the buffers, and there's another issue that I'm thinking about. So let's clean up our code a little bit, refactor, if you will, and start putting a proper draw loop at line 100. I'm even going to use some comments here. Draw loop. The first thing in the draw loop should be rotate the line. Then draw the line. I should probably put remarks on all of these, but I don't got a lot of time right now. Then swap the buffers, which is the subroutine at 1000. That's what a comment would look like. Let's put it in for the Go subs. Oh, oops, Rotate the points, draw the line, swap the buffer, and start over. All right, let's see what happens if we run this. Great, we've got the line. It's not rotating. Why? Because I didn't increase the angle. So on line 140, angle equals angle plus 0.1. And then line 150, go to 100. Aha. It's still not working. I know why. Do you know why? Think about it. Let's go to that subroutine at line 500. This is where I take point A and point B and connect them by plotting a line. But I'm looking up the location of index A and B in the points array, and the rotated values are in the RZP array. Rotated by Z points, RZP. If only there was some generic way for me to pass an argument. I don't think this is gonna work. I know it's not gonna work because I just tried to do it for like a half an hour. So I'm just going to hard code in the rotated Z array, and we'll see later if I have to do multiple rotations how I'm gonna handle that. And guess what? Now's the time for a beautiful fancy editing. Escape. All the way over, and then R, Z, P. And then, of course, I have to arrow over to the end of the line. Go do something else for a little while. It'll be a bit. Looks good. Okay, so there's a nice little point all of a sudden that happened here. This is not working. Oh my goodness. I made a ridiculous mistake. Look at this. I left my old draw loop in there. The one that is not applying the rotation or doing anything. So I've got to get rid of that. 50, 55, 60. Now I just pray here. Oh, wow. Oh my God. Wait a second. Okay, but clearly the buffer swapping is not working, but I don't care because that is totally awesome. Thank you. I'm done. I'm out of here. It's the end of this video. You figure it out yourself. All right, why did the buffer swap not work? Look at some of my reference research here. Oh my goodness. And it was running so fast. You know why? I forgot to have the clear the background step. Should the clear the background be part of the swapping of the buffer? I don't think so, because ultimately it's really part of the draw loop. Yeah, I like swapping the buffer at the end. So 150, swap the buffer. 160, go to 100. And then what I'm missing there at 105 is not swapping the buffer. It is call the erase the background, which is call 62450. And this is gonna, I think, fix it, but also make it run unbelievably slow. That's not that bad, actually, to be perfectly honest. There's my rotating in 3D line. Let's make it a whole square that's rotating. So now my points and my rotated Z points need to have 4 points in them. 4, 3. 4 XYZs. It's funny, I'm not doing anything 3D, but I will. Then let's just change it now. Let's change it to a rotation by X. So let's just do those all in one line. Do we want to see it rotate by X? Let's do Y. So now when we're initializing the points, which should probably be a subroutine, because I'm going to run out of space, but that's fine. Yeah, that should be its own subroutine. Let's make that at 5,000. And I'm going to do all the points. -1, -1, 0. I should really use a Z value, since I have to fix that one anyway, because if I'm eventually going to make a cube, there's got to be 4 points in front and 4 points in back, with like the center of the cube as the center of our 3D world. So let's draw a cube in front to start. Let's draw one in the back to start. Okay. And then, so I'm missing colon there. And then this should be -1, because it's important to have the Z do something. Now I'm doing the third point, the bottom right, 1, 1, 1, 1, -1. The last point, -1, 1, -1. Whoops. I hope this works. So instead of initializing the points here on line 30, we're just going to say go sub 5,000, and then I forgot I need a return there. So even if I run this, I was gonna say it should work with just the first 2 points. Syntax error in line 25. Oh, I forgot the dim. I got so excited I forgot to type dim. Dim RYP 4,3. So exactly what we had before, but now, where is that? Where's my draw loop? Oh, so first rotating them all, 2020 needs to be 0 to 3, because there's 4 points. And then 120. So now I'm gonna need a lot more things there. So that should also be a subroutine. I mean, that's a little bit nuts, but that's fine. Do I have anything at 6,000? No, okay, so 6,000. Draw lines. Oh, REM draw lines. So first connect 0 and 1. Whoops, 56. I hope that wasn't a line of code. Then connect 2 and 3. Then connect 3 and 0. So I could do this in a loop, but I just want to hard code it to know that it's right. I'm also anticipating having a lot more points with a more elaborate shape, and at this point right now, I'd rather just type it all out. And then 6050 return. So that's my subroutine here to connect all those lines. Then let's go back to my draw loop. And instead of line 120 being this, we're gonna say go sub 6,000 REM lines. Okay, let's run this. Look at that. Hey, guess what? We've got to make this 3D. So I need to add rotate X. Do you remember the matrix math we did? Now we just need to add that in. Where does that happen? Where was that subroutine? 2000. So right after line 2050, that's where I've applied the matrix rotations for a Z rotation. I just need to do the matrix multiplication for an X rotation, a Y rotation. I mean a Y rotation. So let's wipe out 2060 and 2070 right now. And 2060 would be RYP n comma 0 equals cosine 0 sine, 0 1 0, negative sine 0 cosine. I think that's right. Then 2090 would be next n. Really should apply the Y rotation first. I guess it's 6 of one, half dozen of the other, because now I'm gonna have to adjust the when I'm drawing the line. Oh, whoops. 2090 is next n, 2100 is return. Let's just run this. We shouldn't see the Y rotation yet, because I'm still just drawing the RZP points. And you can see it's actually running faster than I thought it would. I'm quite impressed with the speed of this. But where is that? It's here. The subroutine at line 500. I now need to change this again. Talk amongst yourselves. All right, everyone. Moment of truth. I can't imagine that I didn't make a mistake, but that's happened to me before. Let's just run it and see. Ooh, where's it going? Goodbye. Where are you going? I mean, I see some kind of 3D rotation there. I think it's because it is out from the center. What it's doing is, imagine it's this piece of paper. What I'm doing is rotating it like this, as well as doing this. So it's really doing this, which I think is what I'm seeing. Let me show it to you sped up. Very slow, but working. All that's left for me to do now is really a lot of typing. I need to add 4 more points so that I have all the points of a cube. I need to draw 8 more lines so we see the full cube. And then maybe if I'm feeling a little saucy, I might like to add the x-axis rotation. We'll see. Step 1, increase the size of my arrays. I realize I did something a little wonky here. It's correct in that I have 4 points and 3 dimensions. But the index values are 0, 1, 2, 3, and 0, 1, 2. And AppleSoft BASIC expects me to put not the length of the array, but the maximum index, which is weird, but that's how it wants it to be. Let's correct it as I expand it. Oh, that looks wrong. But 7, 2 is a 2-dimensional array, 8 by 3. Let's add an X rotation. Okay, my arrays are bigger now. Where do I initialize them? I think in the subroutine at 5000. Yep, this is where I initialize 0, 1, 2, 3. Let's keep going. I have what might be a clever idea. Instead of typing 4 more lines of code, I can edit these lines of code, changing the line number, the array index, and the Z location, right? These are the 4 points at the back of the cube, -1, to the 4 points at the front of the cube, +1. 5040, index 4. And who knows if this is actually any better, but it is gonna work, I think. Oh, there's a bracket there I have to get rid of. Let's see if that worked. I think I got it. I have now all the points of the cube in my array. Where do I process those points? The subroutine at 2000 is where I rotate them. For once, I've actually done something in a way that makes this really easy to edit. The only thing I need to change here is the loop now goes, instead of from 0 to 3, to from 0 to 7. Now that I'm storing all of the points, processing all the points, I need to draw all of the lines to connect the full cube. That happens in subroutine line 6000. So I need to connect the back of the cube. And then I need to connect the corners of the back to the corners of the front. There we go. Great exercise for any of you watching is what's an algorithm you could design to do this in some kind of nice loop. And I've forgotten the return, which is very important. Uh-oh. I made a mistake with certain lines that I've connected. Let's check that out. Wow, this is kind of cool though. I made a weird shape. I must have messed up my point definitions. 5. Ah! I have found the culprit. I have a index off here in this line 5060. It is index 6 and I left the 2 there. Let's see our cube rotate now. Look at that beautiful 3-dimensional orthogonal cube. I feel like the x-axis is feeling left out. Let's add rotation around that axis. I'm not going to add all that multiply by 0 this time. Let's just do it the simplified way. Then I need next n and return. All right, all 3 axes. What are some ways I could get this to run faster? Sure, I could look into programming with assembly language, but are there even some things that I could do in the code to optimize it? Would not using the call to wipe the graphics background and instead erase the individual lines be faster? What about pre-computing all the values of sine and cosine that I might need and storing them in a big array, a lookup table essentially? This would also have the advantage of allowing me to maybe use different angles for each of the axes to get a more complex rotation. I would love to hear from you. How would you optimize this code? I will include a link to an emulator and this code that you can run there and try out different ideas. And if you've got something, let me know in the comments. I will definitely address it in a future video or live stream. Another challenge I'd love to offer you is to add perspective projection. This is kind of flat because it's orthographic projection. And the math for doing that, it's all described in my 3D rendering processing video, and I will include information about how to do that in the video description. See if you can get that to work. I'll show you what it looks like also over here. Hope you enjoyed another episode of Coding Together. What should I do in the next one? I'm thinking, what about music? Could I play a delightful tune here with my Apple II Plus computer? Stay tuned, and I'll see you next time on Coding Together. Oh, and let's not forget to save our code. Disk full! Oh no! I've got 32 gigabytes on this SD card. What are you talking about? Don't worry, I'll have this figured out by the next time you're watching this video, and the code will be linked in the description. See you next time.